the formula for the n root theorem? N root r cis of what?
Theta over n.
Of alpha.
Of alpha.
Remember that? And alpha is equal to what?
A
Theta
theta
plus 360 degrees
divided by n.
K, right?
Okay.
Divided by n. Okay? Those are the two very big formulas in chapter, in unit 3, right? So you really want to nail this down, right? Okay. So J-Lo. All right. Okay. So using that, okay, so now they say use the Moore theorem to find the exact value of square of 3 minus I raised to the 7th, right? Okay, so now, and let's say express in the rectangular coordinate. Every time you hear the word rectangular format, what do we need to do?
X and Y, you need to
X plus Y, right? X plus yi is rectangular.
Yeah.
And then if they ask you for a polar,
R theta.
R theta, right? Yeah. And remember the
Theta.
relationship between the two? How do we find this? So what R equal to? X squared plus Y squared. And then what if we want to find theta? What is that equal to? Inverse of tangent of Y over X. JD, Mr. Jury, wait up here.
Jordan.
What they call it? Judge? No, JD. The last time came up with nothing about JD. What did we call it last time? Something about the judge. Okay, we'll come up with something. So, all right, everybody agreed with Jennifer, right? We good right now? Okay, so now using that and the Moore theorem. So what do we need to first? The theorem says R cis theta equal this, right? So what we need to do, in this case, what do we need to find out here? R, and then theta, right? So we can, once we put it in this format, we can apply the formula, right? So what is the R in this case? Well, first of all, when you see something, what is X equal to?
Square root of 3.
Square root of 3. What's Y equal to?
Negative 1.
Negative 1, right? Bingo, right? Okay, so what R equal to?
Y equal to square root 3
Okay? Square of 3, square, right?
plus negative 1.
Plus negative 1, what? Square, right?
4, which is 2.
Okay, so now basically it's 4 up to 3 plus 1. So square root of 4 equals 2, right?
2.
So R equals 2. What is our theta equal to? Using this formula right here, right? Negative 1 over square root of 3, right? Or it's
Square root of 3 over 3.
what's that?
I mean, like the.
Yeah, so it will be tangent of minus 1 of square root of 3 over 3, right?
Yeah.
What is tangent of minus 3 over 3?
It's 330.
But, well, the way to use
Could be 330 or
the unit
150.
circle here.
It's 11, 5, or 6. Oh, no, right, I was thinking something else.
Okay, tangent is y sine over cosine, right? If you take square root of 3, 1/2 divided by square root of 3 over 2, so you have 5 pi over 6, right?
Wait, then you do that again.
Okay, so negative. Okay, from here to here, you're okay, right? So
Yeah, that-
okay.
that's fine.
So the tangent of negative minus 5 pi square root of 3 over 2, square root of 3 over 3 is pi over 6, 5 pi over 6.
Why it doesn't like?
What's that?
Why it's not like the fourth quadrant? Here?
Okay, let's take a look. That's a good point. Okay, so let's look. X is positive and Y is negative. What quadrant are we in?
Oh, second.
Okay, this one gives you in quadrant 2, right? All right. It's a quadrant 2. That is 5 pi over 3 is in quadrant 2.
Oh, that's quadrant 4.
And X is positive?
No. X is positive and Y is negative.
That's quadrant 4.
It's not positive.
Quadrant 4.
Quadrant 4?
Yeah.
Quadrant 2 is the opposite.
Yeah.
Quick.
Oh, yeah.
Quadrant 4.
Quadrant 4.
Yeah.
Because
X
cosine is
plus
positive and sine is
and
negative.
Y negative. So it's on the
He
four.
said 2 first.
Quadrant 2 is the opposite of that.
Yes.
He was pushing me.
Yes.
Yeah.
No, I think a man is putting on reverse. You're running backward now. Yeah. So, okay, are we on quadrant 4, right? Yes.
Yep.
So it's a quadrant 4.
What he was
Then-
saying, 11 pi over 6.
I asked him.
Then that would be, what's the equivalent for this one?
11 pi.
11 pi
Yeah. That's
over 6, right?
I was like saying 330.
Yep.
He was saying
Okay.
11 pi over 6. and I was like,
All right. So, yeah,
Yeah.
yeah. Sean got it, right? Okay, all right. Mr. MD. MD here. MD, yeah. Oh, I'm sorry. Why you keep going, MD?
Come on, no, MD.
MD.
I can go.
Who was